We make many types of decisions using independent cognitive processes, like memory and perception. We also experience confidence in these decisions. Is confidence then computed independently within each of these distinct processes, or does it reflect a single cognitive process across all decisions? If confidence comes from a single common process, then we would expect individual differences in confidence reasoning to correlate across distinct tasks. We'd also expect confidence to use a single common unit, which would be more efficient than using the original units, which are not directly interchangeable across different kinds of decisions. Importantly, if this is truly how confidence is computed in the untrained human mind, we'd expect to see both these signatures appear in childhood. Here, we conduct 2 studies on children aged 4 to 7 to test each of these predictions. In the first study, 111 children provided confidence judgments on 2 tasks that we believe to reflect distinct cognitive processes: episodic memory and area perception. Let me show you what this task looked like. In the memory task, children saw a series of colored images during an encoding phase. Then we presented images in the 2 colors and asked which one they saw before. After each answer, they provided a confidence judgment on a 3-point scale. In the area task, we asked which shape was bigger, and then asked for a confidence judgment on the area trial. First, we want to confirm that these are in fact distinct decisions. Looking just at their accuracy at choosing the familiar picture or the largest shape, we saw no correlation between the 2 tasks. This means that any correlation between confidence in the 2 is not because of underlying similarities in those types of decisions. So what do we find in their confidence judgments? We see no correlation in confidence reasoning. In fact, we repeated this analysis with several metrics of confidence reasoning from the literature on both adults and children, and there was no clear evidence of a correlation in confidence reasoning on the memory and perception tasks. In our second study, we asked whether confidence uses a common unit across distinct decisions. So far, we've tested 33 children aged 4 to 7, and we asked them to compare their confidence across domains, something that should not only be possible, but just as easy for children to do as comparing confidence from within a single domain, if there is a common unit of confidence. Here's what this looks like when children compare their confidence within a domain. We ask an area judgment, then another, then we ask children for a confidence comparison. Which one are they really sure they got right? Children must compare 2 confidence judgments about the area task, something we'd expect would use a common unit because they're the same type of decision. Now let me show you our test trials, the across-domain comparisons. We ask for an area judgment, then for a memory judgment, and then we ask their confidence judgment. Here, children must compare their confidence in the area judgment against their confidence in the memory judgment. We want to know whether this is possible, and if so, whether it is just as easy for children, reflecting a common unit of comparison. So we do find that this is possible. Children were more accurate on the high confidence chosen items when comparing across domains, a signature that they were generating and comparing a meaningful confidence signal. But was this just as easy for children to do as comparing within a domain? No. The difference in accuracies is larger for within domain comparisons than across domain ones. This suggests that it was harder for children to make those across domain comparisons, which we would not expect if they computed confidence with a single process that had a common unit of comparison. Returning to our question of whether confidence is computed through a single common process, we don't find evidence to support either prediction. Our data therefore suggests that confidence may be computed through independent processes for perception and memory.